Welcome to Unit 3, Lesson 4. This is part 1 of a two-part video. Today we're going to be talking about multiplying a fraction by a fraction. We're going to start off with a question for you. Suppose you sawed a board into 4 equal pieces. Each piece would be 1/4 of the whole board. So in the center of the screen I have a board and I'm going to saw it into 4 equal pieces. To do that we need to draw 3 lines. Now we can label our lines. This would be 1/4, 2/4, or half, 3/4, and 4/4 would be the last line over here at the end. That equals 1 whole. Of course, the very beginning also, we could call that 0/4, otherwise known as 0. And 4/4 over here is otherwise known as 1. And our 2/4 in the middle, we also can rename that to 1/2. That would be the simplified version and the better version. So here you can see that if we take a board and cut it into fourths, that would leave us with 4 equal pieces. Now let's say you took just one of those fourths and sawed it in half. So we'll take the first fourth here and cut it in half. Now the question becomes, what fraction of the original board do you have now? So when you're looking at this part right here, what fraction of the original board do you have now? Be careful because you can't just count the pieces because the pieces are no longer equal. So it's not going to be 1 out of 1, 2, 3, 4, 5, or 1/5 because we're not dealing with 5 equal pieces anymore. We still have 3 equal pieces over here and 2 now equal pieces within the first segment. So it's not going to be 1/5 because that would mean that all the pieces are equal. So how do we find out what that is? Well, let's think about what we just did. We really just took half, because we cut in half this segment here. So we took half of how much? Half of how much? Half of this segment over here, which is equal to 1/4. So really we have a math problem that we set up now that will answer the question of how much this new segment is right here. It's exactly half of the entire fourth. We can solve that problem now. There's no cross-canceling to do, and of means multiply, so we're just going to multiply straight across, and we get 1/8. So in essence, half of 1/4 equals 1/8. We could prove that. We dissected this segment here into 2 equal parts. If we were consistent, did that throughout our piece of board here, or our fraction bar, and cut every one of these segments into halves, we now see that theoretically we have 8 equal parts. 1, 2, 3, 4, 5, 6, 7, 8, which is where our denominator is coming from. And we were asking what this portion, what part of the board this was, and we can see that that's just 1 out of a total of 8 equal. But you can see how creating the equation here kept us from having to continuously cut each segment in half. We could just simply write a multiplication problem to find the answer rather than to have to draw a fraction bar. Let's go through and label our new fraction bar now. Our first line is going to be 0 out of 8, which is still 0. Our first real line here is going to be 1/8 of the way. Our second one will be 2/8. Notice that 2/8 and 1/4 are the same line. And also realize that if you simplify 2/8, you will get 1/4. These are equal. Our next line is 3/8, then 4/8. Notice on this one we have 3 fractions that are equal to 1/2. All of them are equal. Then we have 5/8 and 6/8, which you will notice 6/8 could be simplified to 3/4. Then we have 7/8 and 8/8, which also equals 1 whole. And now that they're labeled, we could just simply go back and look at our first line and see exactly what the answer was by taking a look at our labels. Our first line is 1/8, and that was what our answer was. What we just did was we two-split our fraction bar. We cut each segment in two pieces. What if instead we split it into what we call a three-split, or cut it into three pieces? We would have to draw two lines in the first segment to cut that into three pieces. Now could you tell me what fraction of the entire piece of board this part is? One part of these three? Well, we could write a math equation. We cut this into a third, so we essentially have 1/3 of this entire part, which is 1/4, which would equal 1/12, which basically means that if, again, we were consistent and cut each of these sections into three parts and made all the parts equal, we would have 12 parts, and this would be equal to one of those parts, or 1 out of 12. Let's go back to our two-split. So let's say we two-split each segment, turning this into 8 segments. Now let's take one segment here, 1/8, this particular eighth here, and let's two-split the eighth. We're going to be able to do that by drawing one line and cutting it into two equal pieces. So now, tell me, what fraction is this part? Let's think about the mathematical equation we can create. What we just did was we took our 8 and cut it in half. And I'm asking you, what is 1/2 of this 8? What is 1/2, this portion, of an 8th, which is the portion that we cut in half? What is half of that 8th? Well, we can do the math. 1 times 1 is 1, 8 times 2 is 16. So the math says it's going to be 1/16. We can prove that. Again, we can go to all of our 8s and cut them in half by two-splitting each and every one of them. And when we're done, we can count our equal places. So we're done, we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and we are correct. The one portion of that is 1/16. Remember, a good student will always go back and watch it again if you didn't quite understand it the first time. We're going to look at another problem now. The problem's going to be 2/3 of 4/5. We're asking, how much is 2/3 of 4/5? We're going to use a fraction bar to solve this. I know that there are easier ways to solve it, but I'd like you to see how to do it using a model. So we need to figure out exactly how many equal parts we need to break our board up into. We have two fractions here with two different denominators, so which one should we be using when breaking our board up? Well, we're going to be using the second fraction here because we're asking how much are we going to get if we take 2/3 out of 4/5. So we have to start with 4/5. So we're going to draw 4 lines to represent our 5 equal places. We're going to label them. This would be 0/5, 1/5, 2/5, 3/5, 4/5, and 5/5, or also known as 1/2. 0/5, also known as 0. Now let's go back to the problem. And we see that we're asked to take 2/3 out of 4/5. I have 5/5 represented here, so I need to show where that 4/5 are. So I'm going to do that by drawing a line around my 4/5. There's my 4/5 here. This is how much of the board we're working with. There's my 4/5. Now I'm being asked to take 2/3 out of each of my each of my fifths, or 2/3 of the entire 4/5. It's kind of hard to take 2/3 of the entire 4/5, but it's easy to take 2/3 of each of the fifths separately. And that's simple to do if we just simply cut each of our fifths into thirds. So we're using the first fraction's denominator now to tell us to two-split, or to cut each fifth into thirds. So you do that with 2 lines. And now we have I'll even do the last one so that they're all equal. And now we have a different number of equal spaces. We could now relabel our fraction bar, and we'll see that when we count all of our equal spaces, there are a total of 15. So we would start, if we wanted to relabel, with 0 over 15, then 1/15, 2/15, 3/15, which when simplified equals 1/5, 4/15, 5/15, and so on. Now the problem is asking us to take 2/3 out of each of these quarter or fifths that we have. So we're going to go in there and we're going to shade or circle. Let's just circle them. We're going to circle 2/3 of this fifth, 2/3 of this fifth, 2/3 of this fifth, and 2/3 of this fifth. And now we can just add up the number of thirds that we circled. We circled 1, 2, 3, 4, 5, 6, 7, 8. We circled 8 thirds out of a total of 15. Now take a look at the fraction, and if you were to do this the easier way of just multiplying straight across, you see that we would get 8 on top and 15 on the bottom. So again, with a model here, we're proving why multiplication of fractions, the method that we use, works. We can see that it works. Now I'd like you to pause the video and complete page 75, numbers 1 and 2 on your own. But use this video to go back to reference if you forget how to do it.